All right, we are on to our next problem. So I watched my octopus teacher, and I find some different frequencies. So I have my frequency list. I'm going to do 3 times pi, 8 times pi, 15 times pi, and then I get 10 times pi. 10 times pi. And these are all in rads per second, so I'm going to divide by 2 times pi. Be careful, 2 times pi. To get them into my cyclical frequencies. And I'm going to look at these numerically. Perfect. All right, if there are no constraints, what would be your choice of sampling frequency, period, and number of samples that you need to accurately sample the octopus? So, largest frequency of my signal is 7.5, so 7.5 times 2. I need to be above 15, so let's say I choose my f sub s is equal to 16. Once I choose my f sub s, I need to be able to hit each of those frequencies, so I need my maximum del f has to be equal to 0.5 hertz. So once I have that, I can then solve for, so my del f is equal to 0.5, and that is also equal to big F sub s divided by big N. So solve here, so my big N is equal to 32, so 32 times 1 divided by F sub s. That will give me my period. You could also get that by just looking at del f divided by, or 1 divided by del f. So get those answers. So that will work. There's lots of different answers, but again, I need to make sure that my sampling frequency is twice as large, or greater than twice as large as the maximum frequency of my signal, and to avoid spectral leakage, I need to hit all these different values. And I do that for those things. So let's see, and let's look at some values here. Delta F, delta T, T, Nyquist frequency, F sub S, and N for each of these curves. So here, I don't see any mirror symmetry. So if I zoom in here, 8, 9, 10, 11, these look like 2.5, actually 5, yeah. So we can go ahead and see here, so it looks like 0.5, 1, 1.5. So for the first one, del F A is equal to 0.5. So that's my delta F. So my TA is equal to 1 divided by del F A. So I know that. I don't see any mirror symmetry in here, so I'm going to assume that this 8.5, 9, my F Nyq, F N Y, F N Y Q, A is equal to 9.5. So then my F sub S is equal to F sub S of A, you have to be careful here, is equal to F N Y Q A times 2. And I could solve that my del F A is equal to my F sub SA divided by big N A. And my big N A will be 38. And we could double check that to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Actually, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 times 2, 38. There we go. So I believe that's all of the values that we need here. And then again, 1 divided by F sub SA is going to be equal to my delta T. So we got all those values. I think everything else is there. Yes. All right. So did we sample this signal correctly? My F sub S, what is it? That's good. What is my delta F? 0.5. That'll work. So this one will work, A. What about for B? This is periodic, but again, I don't have, so F sub S, B, or del F B is equal to 1. So 1 hertz. So my TB is equal to 1 divided by del F B. I'm looking at my Nyquist frequency, so my F NYQ B is equal to 9. My FSB is equal to 2 times F Nyquist B, 18. So I can now solve that my del FB set equal to F sub SB divided by big NB, and that'll be 18. And then again, 1 divided by FSB, that's gonna be my del T. Look at it here. So will this one work? Sampling frequency is 18, so that will be greater than that. That's fantastic. But I'm going to have spectral leakage on this one. Here, I do indeed have, I have some mirror symmetry here in this problem. So we need to identify essentially what is going to be that Nyquist frequency. So I have some mirror symmetry, and I can see where it's going to mirror around this center here. So I am going to pick basically the value where that repeats, where it starts. Actually, I have two, I don't have two mirror symmetries here. So I'm going to pick that value here. So my F Nyquist, is going to be equal to, once that repeat happens here, so it's going to be right here. Actually, I see some mirror, yeah, where that mirror symmetry begins. So here, and then it's flipped over here. So my F Nyquist for C is going to be equal to 5. Actually, 4.5, 5.5. So equal to 4.5. My FSC is going to be equal to 2 times F Nyquist C, my QC. It looks like 0.5 there. So for my del FC is equal to 0.5. Solve del FC equals F sub SC divided by big NC. 18 again. So again, I'm going to have signal aliasing. I will not have spectral leakage for the frequencies that I'll hit, but I can get that. And then my delta T is 1 divided by F sub SC. So there we go. That's problem 3. So we'll go ahead and go to problem 4. Again, get out of this here, and then we'll get moving. So last problem, and we'll see you in the next video. Thanks. Bye.